Today we are going to discuss about unicast routing protocol. In unicast routing protocol, there are two domains used to find the shortest path between sender and receiver. Interdomain and intra-domain protocols. In intra-domain protocol, we are using the two algorithms: distance vector routing algorithm and link state routing algorithm. In interdomain, we are using the path vector algorithm to find the shortest path between sender and receiver. Today we are going before going to see the link state routing algorithm. First, routing means transfer the packets from one router to another router. Unicast routing means the transmission from a single sender to a single receiver. It is also a point-to-point communication between the sender and receiver. Today we are going to discuss only the link state routing algorithm. So, which is a technique in each router shares the knowledge of its neighborhood with every other routers in the internet network. There are three keys to understand the link state routing algorithm. One is the knowledge about the neighborhood, and the second one is the flooding, and third one is the information sharing. Knowledge about the neighborhood. Instead of sending its routing table, a router sends the information about its neighborhood only. For flooding means each router sends the information to every other router on the internet network except its neighbors. This process is known as flooding. And then information sharing, a router sends the information to every other router only when the change occurs in the information. Link state routing use the two phases. One is the reliable flooding and the another one is the routing calculations. So in reliable flooding, there are two states. One is the initial state, another one is the final state. In initial state, each node knows the cost of its neighbors. In final state, in each node knows the entire graph of the network. In routing calculation, each node uses the Digistra's algorithm on the graph to calculate the optimal routes to all the nodes. So in the link state algorithm, also known as Digistra's algorithm, which is used to find the shortest path from one node to every other node in the network. So what are the features used in the link state routing means first one, you have to find out the link state packet for all the nodes. Link state packet is nothing but a small packet that contains routing information. So in the packet consists of destination and then cost of the destination. So link state database, the collection of information gathered from the link state packet. And then third feature, the shortest path algorithm. So a calculation performed on the database results in the shortest path. And then finally, you have to construct a routing table, a list of known paths and interfaces. So if you want to calculate the shortest path, we have to use the Digistra's algorithm. So in the algorithm, we have used the two phases, initialization phase and then updation phase. In initialization phase, you have to fix the root node. Any one source node, take it as the root node. It becomes in the n node. And for all the nodes are visitor nodes. So remaining nodes are, we can take it as the visitor nodes. If the visitor nodes is adjacent to A for initial step, so then the cost of the distance of the V equal to cost of A comma V. So which means directly neighbor to the connected to the root node, we can take it as the cost as it is. If it is indirectly connected, else distance of visitor node equal to, we can take it as the infinity. So this is the initial step we can use it in the Digistra's algorithm and link state calculation first step. And the second updation part, we have to find the W, that is weightage, minimum weightage of the step 1. So which node becomes minimum weightage, that node will be take it as the W value. So now the W is added to the root node N, and then update all other visitor nodes. Using the formula, we have to calculate the cost. So d of V, distance of visitor node equal to minimum of d of V and then d of W plus cost of W comma V until all nodes in the N. So let us understand how we can find the shortest path using an example. In this graph, A, B, C, D, E, F are the nodes or routers, and then links. Each link contains the cost or metrics of the connected path. So for initial step, The step one, initialization step, we have to take the values. First you have to fix the root node. Here we have to fix in this graph. We have to fix the A as the directly connect A as the root node. Now we can use the all the nodes are the visitor nodes. That is B, C, D, E, F are visitor nodes. So what are all the nodes directly connected to the source? That is root node. We can take it as the cost as it is, and then if it is indirectly connected the nodes, we can take it as the value infinity according to the algorithm, Digistra's algorithm. So here the A node is the root node. And after fixing the A as a root node, so we have to check what are all the nodes directly neighbor node to the root node A. So B is directly connected to A, and then C is directly connected to A, and then D is directly connected to A. So for B, C, D, we can take the cost as it is. So for A to B, we can take the cost A2, and then A to C, we can take the cost 5, and then A to D, we can take it as the cost 1. So E and F, it is not directly connected to the node A, that is root node. It is not a neighbor node to A, so we can take the cost as infinity. So after step 1, we can calculate to go for the step 2. In the step 2, we have to find out the updation part. That is, we have to find out the least cost. That is minimum weightage of this in this table. So uh, So in this step 1, D as the minimum weightage. So we can take it as the W becomes D. The node becomes D. So for you have to fix added to the root node to N. What is our previous root node A? From this D is again added to the A. So after you have to find out the remaining nodes B, C, E, F are visitor nodes. You have to find out the shortest path using the algorithm, that is formula. We have to find out the what are all the cost for in step 2. So visitor node becomes B, and then W becomes D. Using this formula, for calculate the shortest path from A to B, we have to use the value 2 comma minimum of 2 comma 3. The minimum value becomes 3. And then similarly we can calculate the path, shortest path A to C here. So our visitor node becomes C, and then W becomes D. So from A to C, the minimum cost is 4. Similarly for shortest path A to E, the minimum cost will be 2. So in step 2, the D minimum step 1 minimum cost is 1, that is a D value, D node. The D node is added to the root node, and then you have to calculate the shortest path B, C, E, F. So for B already calculated 2, and then D 4, E value 2, and then D becomes infinity. And then similar way you have to find out the for here in step 2 we have to find out the minimum cost. So what is our minimum cost? That is D node. So D becomes we can add it to the root node. And then again in step 3, before going to step 3, we have to find out the in step 2 minimum weightage for the W. We have to find out the W value. And then after find the W, we have to calculate the CEF. So in step 4, we have to calculate C, that is visitor node becomes C, and then weightage node W becomes B. You have to find out the shortest path from A to C. Here for taking the values from minimum D of C, distance of C and B, for distance we have to use in the table value. For cost we have to check it in the graph value. So what is the cost present in the B to C, we have to take in the graph. So for a distance, we have to take in the tabular column. So calculating the shortest path from A to C, so the minimum value is 3. Similarly for A to F, the minimum cost is 4. And then next you have to update the table. So fourth step, A, D, E, B is added to the root node, and then for C 3, and then D value becomes F value becomes 4. So similarly you have to find out the up to last, that is final step. we have to use find all the node becomes added to the root node. So final table becomes A, D, E, B and CF. So in this way we have to find out the shortest path between the sender and receiver using the Dijistra's algorithm, and then you can in this algorithm also called it as a single source shortest path, because we are using single source and then find all other nodes as a visitor node for to shortest distance between the nodes from the source to destination. Similar way again we have to fix the B as the root node, and then you have to find out all other nodes as a visitor node. In this manner we have to find out the shortest path calculation in the link state algorithm.